Probando sonido. Probando sonido. Probando sonido. Ah, está muy fuerte. Probando, probando, probando. Ahora me pasé. Ok. Probando, probando. Probando, probando. Probando, probando. Probando, probando. Ah, ya creo que está bien. Hello everyone. If the audio is not good, please let me know. So today I want to try improving. So I have the IDE that I have been developing. So let me just show you how it looks. I'm going to create a new folder, an empty folder, and just change into it. So the way it currently works is that you just type UxnIDE and it will show you the usage. So you can pass M or manual. This is so it doesn't auto reload, because if you need to pass input uh, through the console, it doesn't work. I have not managed to make that work yet. It kind of works if I use socket, but it's not reliable, so I don't really know what I'm doing. Then we can have the format option. This is to use Oxen4 to format the source code. You can pass also a relative dir path. This is useful in situations where you are not in the, like you are, for example, in source, but you would like to build on the root dir of a project, and so you don't have to change back and forth. You can just pass this directory, and then all addresses will be relative to this. For example, um, let me create another folder. Let's call this inner, and we go back to inner here. Okay, so right now I am in bus inner. I could, for example, I could also make another dir bin. Okay, so the tree is like this. We have bin and we have inner. So I change into inner, and I also have this alias. So I use IDE, and then the directory will be the top one. The file that I want to create, if it doesn't exist, it will create a template file. So I want to create the file here in inner. I should have called it source or whatever, but we are at inner. Let's say it's foo.tal. But I want, if I don't pass any more options, because I have the file here, and then I can pass optional arguments. Let me think. I think this docstring is wrong, because I should be able to do as well dot. Oh, not dot dot. So also, for example, this would be inner foo. Even though I'm in inner, since we changed the directory, it would be inner, and then it would be bin foo.run. And as you can see, it creates a new file. Let me use all the space I have available. So it created a new file, an empty file. It automatically assembles it and runs it. By default, it uses colors. You can drag the panes. There are shortcuts, so you can like move them around. Like there are configurations in which we could use tmux, like Tilly in Window Manager. With one, for example, we could have one area which is like the main focus, and other ones that when you click, they pass to the main window, so you can see them maximized. But I haven't gotten to that. That would be very cool. So right now we have the xdump, we have the linter, we have a disassembly of the code, and we have the symbol listing. We also have a REPL here. We can only do one time evaluations. So for example, if I hit enter again, every evaluation is like a clean state. It doesn't store a state across evaluations. And just one shell here, so if you want to run something else in the background, you can have it here. Okay, so right now we were discussing in the ear channel, me and other Oxners, about adding some kind of uh, debugging support to the emulator. Okay, because for example, this dump is of the ROM file. So this can, I mean, this is only updated when I change the file, but at runtime it doesn't never change. Uh, the file, the disassembly. So yeah, basically all this is like static. But it would be cool if let me open a bigger file. We can click here where it says CBQ to exit. So let me copy. I have in lib driftblim itsy test acid. I'm going to copy the acid.test tal. It is a test for the Uxtal assembler, and I can run the IDE with this file. Okay, so it automatically runs the file. But now I have here more output to inspect. For example, it seems there are a lot of warnings here. For example, the linter can tell us if something is redundant. For example, this expression is redundant. We have a buffer that doesn't have a name. This is redundant, but of course this is redundant, so we can test in the syntax. So it is like exercising all these cases. Then here we have a memory dump. I am very proud of this routine that it uses awk, and I color the routine. Let me show you. So for example, I can open here. Oh no, but I lost I deleted the history. But anyways, what I wanted to explain is that all the 0 is in default color. All the magenta ones are from 1 to below 20 hexadecimal. For example, here we can see there is a space. Or oh no, it's not a space. Here is a space. From space to the last ASCII, visible ASCII, from the standard ASCII is in green, and above that is in red, and FF is in cyan. So I think that with this it is very easy to spot with some bytes. Everything is aligned. I put here a new line so we can distinguish pages, and I also separated these columns here so it is easy to count the bytes and all that. And then, however, we can also run all these programs are just where is the, please give me a moment. Oh, there it is. Yes. So all these programs can be used standalone. For example, here we have the acid.tal. We could use UxnLin acid.tal, and it gives us this information. By default, it uses colors because the idea is that we are able to easily spot the information we want. But we can also, and I want to do this, I want to like have a shortcut so we can save all this textual information in files, like sort of a save state, but visual for human readers. So we can also see what are the options for some lean. Oh no, I haven't changed that. But what we have here is it has the option N or no color. And this is adequate to store in a file for reading later, because if we don't do this, we will have a lot of the color escape sequence scrambled with our text. Okay, and all these routines accept the same treatment. We can remove the colors from all of these. And I also want to make it so later that we can have this theme here in all the panes. so it is consistent, and we also have the set colors. I forgot the command. Oh yeah, color scheme. Monotone light. And I also have defined this other theme. So I would like to have both of these be able to change with a shortcut all the panes. Okay. I also made some adjustments to the output besides the color. For example, I added the @ sign to the symbols, but now I realize that it could also be a macro here. So probably macros should have the percentage sign. But besides that, for example, I also need to catch this one so I don't put another one on reset. But the other ones, I think it is easier just to see that these are labels, or most of these are labels, and then we can correlate them, or the people that are starting to learn or to get interested can see, oh, okay, so this is also a label, right? And I also added here because UxnSIM doesn't print with these @ signs. So all the symbols are cyan, absolute addresses are yellow in all the outputs. I'm going to make it a little bit smaller, like that. So all the addresses are yellow, and here I didn't do anything but colorize UxnDis, which is this one. So we know that the first column is always the opcode, and well, unless it is of course just data, like here it is a lookup table. But if we are in a routine, we know that, for example, this is an opcode, and then this would be the raw like arguments or parameters that the opcode takes. So now let me exit again here, and we can also pass here the no color option, and we can have the panes without color. This is not as useful, but I just wanted to be sure that all the flags were able to be passed down. And let's see, what do we have? We also have the formatting and manual. So for example, manual would be for something like, let's say we need a new file here. Oh, but from the IDE. Okay, and now let's say that whenever we save the file, it will automatically run the assembler and evaluate the ROM. Then it will disassemble the ROM. It will list the rom.sim file, which is binary, and it will also lint the code and dump the ROM. So it's doing a lot of things, but I think it is very useful to have all this information close. So now, for example, I could add, if I add a number like this, oh, but this is dead code. Let me put it here. You can see that the moment I saved, it was updated here, and in the disassembly here, and also in the output of the dump here. Okay, so now let's say that I create a new label, and then we can see that the label is here, and also the output of UxnSim is sorted because it doesn't sort by default. So I have sorted it so when it gets very long, it is easy to do like by section on the list. Then, for example, if I push a short using this syntax, what I am actually doing is using opcode A0 with arguments with parameters 1, 3, 3, 7. Okay, this is what pushes the 2 bytes. However, for example, I could do it this way as well. And while it is equivalent, in the actual source code, you can see that now instead of using 3 bytes, we are using 4. This is the operation to push just 1 byte is 80. So now we need 2 instructions to push 2 bytes, and oh yeah, right now when you see this in the top right corner is because you are in the scroll back buffer. You just press here escape, and now you can see that this updated instantly. I'm going to do it again. So we don't have any warning there, and now we have the one. And it's just telling us we should combine these 2 expressions to save 1 byte. Okay, so I think that's already pretty useful. Another example could be, for example, bar here, and it just calls full, but immediately after that it returns. So now it would tell me that we have a tail call here, or we should have a jump like this instead. So now instead of calling into foo, returning from foo, and then returning from bar, we jump directly to foo. Of course, here foo would have to return. So let me just make this like this, and this one returns. Then the one we actually call is bar. After that, we check the stacks. Okay. So the output is the same, but now we have several warnings. We have the tail call, which can be fixed by just doing this, and then we have tail jump. Oh yes, in this case, since this one is above this one other, you would just need to follow through. But this is just an example, so let's assume, like, I don't know, this is below. Here it's telling me the fall through. Well, it is the same, yeah. But you get the idea. So maybe I should do another file just to highlight all these scenarios. So now that I have all these colored the way I want, I would like to color the actual output of the emulator. So for example, I don't know, the pointer in blue, this pointer marker as well, or maybe in yellow, something that stands out in just a glance. And also, as I was telling you, we were discussing in the ear channel. Currently, we only have this routine for debugging, and we need to call it this way. So we push one non-zero byte to the 0E device, which is the system debug port. Let me go to the wiki. think that is good. So here we can see the Barbara system has this debug port, and it only triggers this routine that prints the stacks like this. But of course, we could do many more things. Things that would be useful to have for debugging is, let me see, dump memory, dump the RAM, the device page, probably the zero page, like having a standalone. And the way I'm thinking this could be done is like with an enum. Okay, so we would have a like an enumerator, and also probably it was mentioned that everything above 80 would be like an actual breakpoint. So this would be a breakpoint. I don't know what's the name. What would be a good name for this? Like, I guess it's a message. So debug messages, and this is like an enumeration, but it has to start at 1. Okay, so we would have something like the current one we have, which is the stacks. Then another one could be for RAM, probably by default 1 page. I mean, it could be more, but let's just say it's 1 page. And then, because this could also generalize to printing the stacks, but not in this manner that we have here. I mean, like dumping the whole thing. Like this. So for example, this would be this could represent either the working stack, the return stack, or the device page, as well as the zero page. For the devices, well, I think it is useful to have the ASCII columns either way, because yeah, I mean, I don't know what people are going to be using this. Maybe they want to store strings in their devices or whatever. So that should be up to the user. So it would be a routine like this to print these 4 elements, which is the stack individually. So for example, I would say working stack and the return stack. This with their pointers, working stack pointer and return stack pointer. And then also the device page, and some way I mean, we can get the program counter in UxnTal, but it is a little bit inconvenient, because for example, sometimes we are using code that uses relative addressing, and if we start putting a lot of instructions for debugging, then we break the code, because then the code is too far away to be called by a relative reference. So what I tend to do is I have to go change those to absolute addressing, so it works for whatever I was testing. But then I have to remember to go back and change them, and sometimes I just forget to do that again. So it would be cool that all this takes like very little instructions, so that we don't suffer that, or at least we can mitigate having to spread the code every time we insert instructions. So the RAM, the device. So also it would be nice to have to pass the length, the a bank, and the base address we want to see. And I also need to remember to check what my emulator do with cross bank boundaries, because I have not tested that. So this would be useful. This is just the default routine, but with colors. And then yes, the PC as well. Or maybe we can just add the PC to this routine, or have like a little for example, there is a cool project. It's called Astra 256. It is this little game that has this like panel. Let me see. So something like this, that has all the information, like a summary. This is the disassembly, like 1, 2, 3, 5 lines of disassembly. Then here it has the registers. Of course, the only registers we care like individually are the stack pointers and the program counter. But then we could have like here the small view of the top of the stack. And also here we would have a little like a snapshot, or like a peek of the disassembly. And here we can represent one page. It could be a full stack, the device, or just one RAM page at a time. And just it would be nice to have like some way to move around those, like with the arrow keys, or something like that. I like this kind of interface. So where I was. So that would be, here could be the PC. And also we already have the PC, the stack, the top of the stacks, and the stack pointers. So we wouldn't need to have a separate thing for this one. Let me save this. Okay. Another thing that could be useful, for example, is to have a real breakpoint, something that actually pauses execution. And then once we give control to the emulator to debug, uh, that all that API is on the side of the emulator. So we would have a lot of more freedom to do whatever we want with our emulators. It was also discussed about a debugging device, but precisely because of this reason that we yield control to the emulator. We break the illusion of the virtual machine, and then it doesn't make that much sense. But another thing that I thought is to use one of the no op opcodes, one of these, in order to have just one byte signal the emulator to stop. I think that would be better instead of having to do something like dot breakpoint dot system debug deal. Okay, because this is, and we can check here, this would be 5 instructions. Okay, so imagine that you have here a label foo, and on the other side here you have a reference, but it is a relative reference. So sometimes you may have a lot of code in between these points, and 5 instructions, for me it's just too much to set a breakpoint. So ideally what we could do is for example a breakpoint, call it BP, and that could be pop key could remain being like the default knob, but a variation like pop keep R could be this breakpoint. So instead of having these 5 instructions, we just have BP like this, and that would be more amenable in my opinion. Okay, so that would be another option. Then we have four knobs. One could be a true knob for whatever purpose. Another one has been discussed, at least not in any kind of convention way. But for example, I would like to experiment using one of these to connect to a coprocessor, and this other one could be for a breakpoint. And then what could the other one be used for? That is interesting to think about. At least to me, it's like a little puzzle. So yeah, I mean this could remain the same. And in the event that we need to pass all this information, then it could be some sort of system expansion. Uh, it would look something like this. Uh, like we would call the system expansion, send a command, and the command would be something like the length we want to dump the bank, and the base address. So let's say we want to start at the reset vector, and we want to print, well, to dump one page. This would be the values, but since this is a command, all this has to be in raw bytes. And of course the command would know that it should read only 6 bytes ahead for the command. Okay. So that is another option. In this case, I think it is more useful to have this, or at least have it well, no, because I mean, how would you know which bank? It would be too constrained. So yeah, so it is 6 bytes. But the other option uh, is to do it manually. So instead of doing programmatically, just have like, I don't know, F7 just breaks at the moment you pressed, or well, at the moment it detected the press, right? So like pause, and then F6, F what up? Oh, F8 could be. Oh, my keyboard is broken here. What happened? Oh, there you go. Yeah, F8 could be like play again. So I think this interface in the long run is going to be more useful once we have paused. But in order to actually pause at a very specific point, then we need the breakpoints, and I think this is the best approach to implement them. Because yeah, what else could be? Maybe a GUI where you can specify like something completely out of the virtual machine, but I think that would be like too much for too little gain. Like some balance in between all these approaches would be the best. And just to determine what is the best approach, we just need to experiment a little bit. So now about the emulator itself, let me see. I want some kind of Frankenstein for the emulator for the occidental koans, and also for the UxnIDE. I want something that is like UxnCli, but also has the fork app API of UxnCli 11. It also has the raw PTY API as UxnPTY. It also has a timer vector like UxN11. So it would be like the screen vector, but just for timing. So only the screen vector implemented for that device. There wouldn't be like X, Y, and all the other ports. Then I want to have flags for colors, for the sandbox, for the fork API, and for the raw API as well. And then I don't know, something like max steps. So just parameterize the virtual machine a little bit. And I think that's it. Yeah, because I don't mind having the debug enabled for this, okay, because I mean it's not even a graphical emulator. So what I'm interested is in having more like an emulator, like a simulator, if you will. And the max steps, and I think that's it. Colors, sandbox, fork API, the raw API, what else have I needed? It would be very, very cool to have audio without a window. And I know it is a hassle to do it portably. I'm not very good at C. I'm going to try to do some C today, but you will notice I'm not very good at it. So I don't really understand the audio device to implement it and also to do it portably. So I will probably have to use a library for my emulator. Um, but anyway, that's not a big issue. We can always change it to something better later. And that's it. So for today, let's explore what will be the base. The base I will pick and then just paste. Well, like try to port all the other features. I think UxnCli 11 is the best choice because UxnTTY it is like I understand what the changes were. Uh-huh. And I have implemented this in UxnEMU, so yeah, we will have to actually I think I have here the if I go to lib cd UxnTTY. mm, so yes, this is the patch that I made. So I already have this working, so I already have the timer. This is done. Okay. So the timer is done. Oh, also I need to add here the debug routines. Like printing, let's call them printing routines, and play, pause, and stop, step, and also speeds like slow speed and fast, and maybe just like some few discrete uh, intervals between this. This would be kind of like it's how it's called this game, human resource machine. Yeah, so this one. So here, for example, it has the stop, a step. Oh, and this one can actually step back. So that would be very interesting to implement. Yes, of course. So a step and a step back. Okay. And then you have like a speed slider here. Um, yeah, something like this, and even maybe even try like to gamify the interface so it is like fun to use. Because yeah, like this could be a game in the future, like a TU textual user interface game. Okay, and let's look another cool design that we could also take inspiration from. I like a SICK one. Uh, this one as well has like the memory of the SIG one is just one page of UXN RAM. But like if we had some sliders here, we could actually like see through all the memory. And also, oh yeah, of course, one of the greatest inspirations would be UxN32 emulator. Oh, and this one, this is the debugger for UxN32. So you can see we have this, we can see the address. We can put here the address we want to jump. And then in here it has like a scroll bar. But maybe we could do only with the buttons and with some keyboard actions. Then it has here some information. It has a count of the ops. That's a nice touch. The PC, the the state. Then here is the device page and the stacks in this fashion. So I think for textual ASCII representation, the stacks in horizontal is better. And if we really need more of the stacks that than what the peak allows us to see, then we can dump the whole page. That would be easier. And here is the disassembly. The only difference is that I like very much how the assembly looks like this. Let me see. Like this with the so if you for example copy this and paste it here. So this is actual valid occidental code. I can remove this. Uh, for example, it would be something like here you start at 100 hexadecimal, and so here we are 3 bytes, so we would be here, and then the next one I like to put it as well, just as reference. So this is completely valid occidental syntax. I also made the same for the symbols. So it is valid to just copy paste them. And also this hex dump is completely valid occidental code as well. Okay, because this is a comment. Mm. Oh, and this has a big step. Big step and just one step. And big step. Please give me a moment. My doggy is having a nightmare. Okay. So now let's start exploring a little bit of UxnEMU as I have it. Let me just say what I have before I lose this. So we can remove, what is this? Oh, so this is the example of using the timer. I'm going to save this. So let's move this to timer. test down timer. So let's move this to source. Then the patch, I don't need it anymore. I changed the made file. No. Okay, so this is the patch, the timer. Oh, I did the main file. Yes, it's just this. I didn't remember. Okay. So let me test the make. And this is the demo running. So this is using the timer device to print this star, which is better than just using the daytime device. Then we would only have like 1 second resolution. It would be too slow. So I haven't actually made a game with this, but I would like to try. Mm, okay, let's remove all the test thingies. Then there is a femto. And what is this other make file? Okay, so this is the original. Okay. Okay. So now let me just save the changes. The checkout P. Let's call this UxnTUI. And now git add everything. Implement the timer. What? Okay, now let's open that file. It is in lib uxnTTY.c. Okay, so here it is. And this emulator is very easy to understand, in my opinion. And oh, we can use the trick I learned with enter. This is, by the way, this is what makes the IDE work. And let me show you. So here in UxnIDE, basically here we are just checking the options that we take. Then we use RL grep for some of the programs. And here is where I start making the paints. And for example, if we go, or wait, actually, I think it is easier to understand because here we call something that is the watcher. I don't remember what I did. The command was done here without the color flags. Oh, here it is, the watch command, but I construct the command. Well, the important thing is that we use this other script inside this one, and this is the one that actually calls the routine we want. Okay, so which is this one is the enter program. So you echo the name of a file or a bunch of files, and then enter will evaluate the following command every time this file changes, which is basically what the IDE is doing, and that's all there is to the backend of the IDE, just this command. So we could do something like echo UxnTTY.c and then pipe that to enter, and enter will just run make. Could not load. Oh, it needs test.run. Yes, no, I don't want that. I just need to assemble this. Yeah, I just want to assemble the emulator. So now we can do this. And let's say I change the file here. And that triggers automatically a rebuild for the emulator. Okay, so let's keep this one here open, so I know exactly when I screw up, because this happens to me all the time. Okay, please give me a moment. Okay, no one has said anything about the volume label, so I think they are fine. Okay, so let me do this a little bit smaller. I guess let's go to the beginning and just see what the emulator is about, to get an idea of what we are dealing with. So first, it is using Termios for the, oh yes, so if I use UxnTTY as the base, I already ported the screen. So the raw TTY API is already done by VM. Then the next thing would be to fork the API and put it here as well. This is probably just like a pipe dream. I don't know if I'm going to do this. the flags is low priority and the debug is higher priority. On fork API it is also lower priority. Okay, so we are going to start with some improvements to the debugging. So this one uses this is for the timer and this is for the raw mode. This is for the timer as well. Here we have all the constant, well, all the declarations. Then this is the routine that prints the stack. So this is an easy one. We can do a very little small improvement to the default routine by just adding a little bit of color. Okay, so here I have the list of colors I'm using. But wait, what colors do I want? We were saying that perhaps working stack and return stack in cyan. This bar should be in yellow, so it is easily distinguishable. If it is a null byte, it should be default, so it is like grayed out. And if it is not a non-zero byte, then in magenta. Yeah, probably magenta. And the stack pointers here in green. I think that would be visually good enough. Okay, let me see. Let me just think. Yeah, I think that should be good enough. Okay, so let's start with cyan. So it would be here. And I believe we can do this. So here is the cyan and I'm going to do this the ugly way, and later I'm going to make it pretty, because the least syntax I have to deal with, the better. So we just print this and let's test it. So if I run this, now we should see the output of this. Okay, so let me actually create a test.pal. Oh, we're already here. Yeah, so it was this one. Let's create a new one, because the default one is already calling this and then immediately it exits. So this is good enough. And also for the curious, you will see that it has a shebang, because yes, Oxental scripts is a thing now. Look at this. We can do test.tal and it works, or we can even do it with the ROM, directly to the ROM. Of course, the ROM is just a ROM. It has already been assembled, but for the test .tal, we have the option to pass this variable, so it forces the reassembly in case you need that. Okay. But the important thing is that it exits, because right now my IDE doesn't handle well when the I don't know how to kill the program on save to restart it yet. So I haven't figured that out yet. But this shebang is a nice trick that saves us a lot of time. It is involved with this UxnRun script, and basically what UxnRun does is it will basically parse the shebang, see if the forced option is there, and then it will here is checking the first line to check if we have here the shebang. Okay, the hash and the bang need to be the first two bytes in the file for this to work, just like in a normal shebang. And then if it detects that there is a force option, it forces the rebuild, and finally it just passes the whole thing to UxnNASM, which in this case UxnNASM is just drift beam. And when it reaches drift beam, it will also check all the flags that it needs. But then here we need to create a temporary file in order to strip the shebang, because this is not valid occidental syntax. So instead of hacking in the assembler itself, I just grabbed it and I detect this, so that by the time the assembler sees the file here, it is already without the shebang, and then I just colorize the output. Then okay, so now we have the test. If I run make, oh, it is commented out. I am going to and notice how I'm going to make this much easier now, because I have the test.tal. I can just do test.tal here. Oh no, because this is another emulator. Okay, so anyway, so I can just do UxnEMU test.tal. I don't need to put test.drum because my wrapper takes care of that. It gets tired to have to put this once again and again, especially in the cell phone, because I use my cell phone a lot. So if I just pass one tal file, it will just make in the same directory the test.drum. Okay. Okay, so now I run the enter command, and there you go. So we can see that now the color is blue, and if I try to save this again, oh, so let's say I change the color here. No, it is actually not returning. So maybe UxnTTY, oh yeah, it is different from OxnCli. It will not terminate. So I need to tell it to terminate myself. that's just 0, 1, 0 DL away. Okay, so now we do this. There we go. So now it has ended, and probably the color here changed because make. Really? Okay, because if that is the case, I don't want to use make for this. Let's just make this a script instead. Okay, so we just compile, assemble, and run. Oh no, I was the one that changed the color here. Yeah, that was weird. Okay, but anyways, it is working, and I don't like the extra output of make. So a script is fine. Now we are going to do the enter command again. But now we need to echo this like this. Okay. Okay, so this is the output. Now, once we print the name, we want to return to the default color. The default is just M. Mhm. So that would be after the string here. Let me test this, and there we go. So now we print only this part, and the rest is in the color I want. The bar here needs to go in yellow, but this is, oh yes, this is conditional. So I guess the next one was actually yellow. Yellow. Uh, but that is only for this one. The moment we finish printing this one, we go back to default. X1B. There we go. So in this case, it is not there. This is to print this bar when it is at this point. Okay, in yellow. And we can test that with we can just push a bunch of numbers here. Like that. And then we can see here that I pushed 8 bytes on purpose so that now this bar is all the way here, and we can see that it is correctly in yellow, and then it turns to normal color. Okay, so now we would need to do, yes, because I just need to check now if the value is 0. Okay, so for I, but then this is where I think we need to now put the braces. And okay, I'm start. So this is going to be, let's just copy all the colors. So we will need to do fonts, char, and then this equals x1b, like that, right? Oh yes, and we need the semicolons. Then this is not needed. Okay, let's see if it assembles. Okay, and here it fails. Oh, it doesn't like the const. I'm sorry, C. So this is running the stale ROM, because here this is failing. Ah, dang it, I don't like C. Parasite in the, oh yeah, this is not valid syntax. Of course. There we go. Is that better? Yes. Okay, so now this would be another string, another string, and another string here. And then the parameters are name. Oh no, it first is cyan, then is the name, then is yellow, then this, and then we go to default. Okay. It worked? Okay. Now, where were we here? Okay, so here, let's say that to do this in C. Okay, we are trying to do the same here, but the color is conditional, except we know that for the bar thingy, we are going to print yellow, and just after that, default. Then the color behind the opcode here, this would be, oh yeah, I need to do the ternary operation in here. That would be the easiest. So, oh my god, so let's see here. We check if E is 0, the color is default, else the string is what we said, magenta. Okay, let's see. There we go. So now we have these two bars in yellow. This is in magenta, and this is wrong because this one should be, yes, right? Because it's not like in Python. This is, if this is true, then this, else this one. Because here it says if E is FF, then draw the bar, else nothing. Okay. -8. Oh, but we don't need to, we just need to put E. And if it is 0, okay. Okay, let's just continue because is it in the other way around? I don't understand. Okay, but whatever you want. No, because here, let's just print I. Okay, I, and then this. Okay, so the number here is 0, 0, 1. Okay, yeah, so this is the pointer. Oh, but this is the pointer, not the value. Okay, yeah, I get it. So we need to do like this. Then I was right. This is here, this is here, and it is the stack RI, like that. Mm. Oh yeah, I'm sorry. because this the pointers behind. Mhm. Okay, anyway, let's what color should this one be? Probably yellow as well. So this thing is yellow, then this thing is green, and at the end this thing is default. So we have yellow, green, and the default, like that. Okay. Yes, that's what I want. Okay, now let's make... We can also make enter to watch more than one file. So for example, if I also watch test.tal, it is going to run the build again. Wait. Enable to start. Oh, it wants like a globe or something like that. Or it wants the quotes. Oh, bash. No, I don't remember. Let me search. Mm, no. I think it has to be like like find, like the output of find would be proper. Okay, maybe here we have examples. Oh yeah, there we go. So we find reboot a project. If source file is changed, limit an output to the first 20 lines. Okay, let's just do the whole folder. No, this one. Okay, so now for example, if we remove all these, yeah, so now all when it is 0, it will be zeroed out. And I think we are having like a yellow space here. But I mean, it's not that important, right? If we don't want that yellow space, invisible yellow space, just need to... After, let me see. So here is cyan, then this is yellow, then this is default, correct. Then here it is either default or magenta. Then default Maybe it's just not that. Let's remove it. But let's push some bytes now. For example, we want to push 000 and then 1337. And there we go. So that is what I want. The non-zero bytes a little bit more highlighted, and this one we could even invert the color for this one. Yes, let's do that. So I don't remember. ANSI escape sequences. There is a gist. Oh, this one. So I guess it's called invert. Set inverse reverse mode. Escape 27M. Inverse is x1b. Okay. And let's never forget we need the semicolon. Okay, then I guess this one puts it back in normal again. Okay. So now let's put this one inverted and in yellow. Then we set it to default, and then this one here as well. This one would be inverted. Okay, how does looks? I don't think it's working. Or, oh yeah, we could make both. This could be both. So it has a little bit more pop. Let me see. Strike through, blinking, faint, italic, bold mode. Oh, that is the reset sequence. Okay, so this is the sequence. Inverse. And then this is the other one. This is inverse and this is uninverse. And this will be U. So here we have inverse, yellow, pointer, default, and then uninverse. Okay, okay, but it is only if it is the bar. this again. Okay. Mm, no, I guess I don't want that part because it is like too intrusive anyways. I think just the yellow bar is good enough. Mm. Only bold. Bold seems like a good idea. So bold is 9M. I know 1M and 22M is the reset sequence. Okay. String. String. And here is bold. And then it is unbold. Oh no, we said it was normal. Yeah, normal. There we go. I think that's pretty. Okay, so we have the first routine with so here is the stacks. Oh Lord. And then we have one page. Let's start with one page of memory dump. Then play, pause, and all that is going to be another point, and this one is another point. Yes, like this. So we have one for RAM, one for device, then one for return stack, zero page. Oh, and we need to put the pointer, I mean the PC index. Okay. Okay, let's try to put the PC. So when we call system print, and let's just make this a little bit more readable. Okay. So let's give it here a space. It's looking pretty. So when we use this system print working stack, return stack. Okay, it just passes the name and the offset of the pointer. There is no way to expose the PC. So this is the CPU. But we are passing the PC to UxnEMU. So it is mutated here, but then where is this stored? Oh, yes, this. Okay, when we say UxnEval, we pass the PC. But okay, here we say okay, start at this. Yes, it is not part of the struct or whatever. Okay, probably because it is more efficient, less in direction and all that. But we are going to put it here. Okay, let's add it. We need to keep track of the PC. So it's going to be a UN16. And let's call it PC in capital. Then Yeah, because this is not an object at all. It's like just this. The name, the stack, the offset. Mm. But it is global, right? So it should be fine. I think this is repeated. Yes. Okay, so this is not needed. Didn't. Okay. So since it is global, we are just going to take this and assign it to PC like this. PC equals PC. And then all the references here. Uh-huh. Ah, no, I screwed. PC escape, PC save. Why is not working? PC escape, escape, escape. There we go. Okay, so now we are using the global variable. But we also need to use it in the macros here. Because I'm sure we use PC here. Here. Okay, let's see if this works. It seems there is no issue. Let's say we change this. Okay, perfect. Then we just need to pass now the PC in the routine. But where to put it? I'm very bad with these design decisions, but let's see. So this is the current. Maybe we can have PC like this. Oh, but this one is printed independently. I know. Okay, I got it. So what we are going to do is that after the first one is printed here. Oh, a system. What's the name? System print. Okay, here print the first one. Then we it's fprintf or printf. I always forget. It's called fprintf. Okay. Yeah, here. So fprintf, it would be a standard error, then the template, but here it is the string, and then a space, bc, a space, oh, and another space, and here, oh no, that's in the template. So put a space, two spaces, then we want color, I think I only like red to use, so it's going to be red, and then default. Oh, but we don't have these colors here. Okay, let me go. So we just need red and default. So that is red. Default would be like this. Okay, let's see. Okay, let's remove the new line. It must have a new line here. Yes. Okay, so now after this we put a new line, and let's just put a carriers return as well. I put the carriers return because if you enable an application that uses raw mode, you don't want to deal with this when you are debugging. So it is easier to put the return here, and if you are in canonical mode or in raw mode, then it will work nonetheless. So we print this. Now we have here PC, and then let me see. Okay, so now why there is a space there? I don't understand that part. Okay, because the first time it was without a space. But anyways, then here we are going to print here one space and then decimal the BC, but actually not decimal, hexadecimal. And then the format for this is 04. needs to be outside of this completely. So here, after we finish printing this one, we're going to do like this. But in this case, here it is 0 for x, the PC, okay. Yeah, we probably want 2 spaces. And then here I just need 4. There we go. So we have the PC, the stacks. Now why we have this extra here? Because PC has... okay. It's this one. There we go. Okay. So those are the 3 like registers, the 2 stack pointers and the PC. Now I need to change. So well, give me a second. Yes, I guess I just need to copy. Let's copy UxnTTY to .local uxn bin, and then also let's move .local uxnpli to uxnpli, like this. Oh, bin. Okay, and now let's move uxnpty to be uxnpli there. Okay, now this is the emulator that is going to be running on the IDE. So let's give it a try. Oh, let me close this. And here we have the output now. Colors with the PC. And let me recover this. Okay. So what do you think, whoever is in the chat? Do you think this? I think this is better, especially when you start like piling this up. For example, uh, if you do like Okay, I broke something. Let me see what happened. UxnLean is not playing nice. But why? Okay, let me exit. Try again. Oh, we need a carriage return for this one. Okay, let me see. Here, we need a new line under return. Okay, there somehow it is not working with this emulator, because that's the only change we made. But okay, let's try it manually. Doesn't matter, I can fix it later. So oxen acid dot tar, and then oh, actually, you know what? Let's try the timer. Oh, what was the name? Oh yes, I'm not in the repo. Here, so it was timer.tal. Copy timer.tal to what? Was in. Okay, now timer.tal, and here, so this is basically a callback to the timer vector. So on the reset vector, we set this other vector to be on the timer vector device. All it does, it will increment a counter, a tick, and well, here it is like doing a selection of when to run this. But we are going to add here the 010 in the O. Okay, so that we can see the output of the stacks. And then we can just like that. Mm, mhm. Ah, okay, yeah, I get it. So I need to use this one. Like dot UxnTTY timer dot run. Mm, it is not printing the stack. this like this, right? Mm. Okay, no, it's not working as I expect. Okay, yes, of course. It's a new file. Okay. So we have a space here and then we have the star. This is the space. Mm, is it RN or NI? I don't remember. I don't think it matters. Let's put it like this. Okay. Okay, there we go. So now let's just remove the... Let's remove the star. Okay, and now here's 1, 2. I think that's fine. I think that's pretty enough. And we can push something to see the chaos ensue. Okay. But this thing if for the PC is not updating, so I would expect that to also change, of course, because if we check the symbols, what's the name? Timer. Oh yes, yes, yes. It's Oxon PPY, Oxon local UXN bin UXN sim. Fine. Oxon. Oh yeah, exactly. I changed it to Oxon. So there's something wrong with the EMU. No. Okay, I'm not sure what went wrong there, but anyways. Thank you very much for watching. I have to go for now, but I am going to the next step. Let me just revert the move dot local Jackson click back Jackson click. Okay, and now Jackson sim. Okay, now 0119 here is the, oh, of course, this is the, okay, let me open this, and this is why it is very useful for me, the IDE. So if I run the IDE on timer .tag, then I have all this information, right? So we can see, for example, 0119 is this label. It is an anonymous label. If we now go here, it would be in this point. So it is basically when we do the deo. That is why the PC is not changing. Okay, that makes sense. Because if I did it like here, and then one over here, and then I moved uh, mm, okay, now, yes, now we see that some of this is this point, is this PC, then this. Yeah, I think this is an improvement. So I'm good to go for this evening. Thank you very much again for watching. I hope it has been entertaining, at least a little bit. Later today or tomorrow, I'm going to start doing the other yes. So for example, I have oxendump as timer.rom. So I am going to make exactly the same routine, but so that it may be triggered from inside the emulator, just like we are able to trigger the stack printing. Okay, so that will be for later today or tomorrow. Have a wonderful day, and that's it. Thank you.